So let's say we have to make this box. Now obviously the box has three surfaces: the top view, the front view, and the side view. So we have a box, which means we have a baseline, we have a starting point. Now this starting point may be this point, this corner. So that means we go 30 degrees this way, we go 30 degrees this way. We can measure this distance and plot it over here. We can measure this distance and we can plot it over here. So that gives us the length and it gives us the width. Vertical lines will always go 90 degrees to the baseline. So you figure out what this height is, this height, this height, this height, and that height in isometry will remain the same, which means if this is the height that I'm projecting over here, the height over here will also remain the same. The height over here will also remain the same. And similarly, if I were to make the height at the back, that would also remain the same. So let's say somewhere till there. Now, obviously this is an opaque object, so you're not going to see that line, but when you're constructing, make that line, because otherwise what happens is sometimes this part does not remain parallel and that becomes a problem. So you will visually see that there is something wrong with your product. So it's always a good idea that you make it light. If it's not supposed to be there, you can just leave it, because in IGCSE, we want to see how you've constructed. Therefore, construction lines are very important. So we've got our 4 verticals, which means all we now need to do is join them. So one way to make the product is to first make the verticals. Wherever they stop, you join them together and you get your isometric cuboid. The other way is, let's say we don't go with this, which means that we have a 30 degree angle here, a 30 degree angle here, and a 90 degree angle over here. Now, if you notice where I stop, if I draw an imaginary line over here, which is supposedly parallel to the baseline, then I have to go 90 degrees above to get the vertical in place. Same is true for this point. If I make an imaginary baseline over here, that is going to be parallel to the baseline as well. And from here, if I have to go vertical, I will use a 90 degree. Now, one thing in geometry that you should remember is, if you have 2 parallel lines and one line intersecting both, this angle, that angle, this angle, as well as this angle are all the same. So if this is 30, this will be 30, that will be 30, and so will this be 30. So if I look carefully, I will notice that this parallel line being intersected by this line, so you can extend it further, give you angles where this is 30, therefore this is also 30. So 30 here, 90 here, equal to 120 in total. So one option is that I first create the parallel baseline to this line and then I create 90 degrees. The other option is that as soon as I stop over here, I know I need to go 120 degrees, so I just put the protractor here, get my 120 degree, plot it, make the vertical line. So you have both options, and you will notice if I were to start my line from here and I go to whatever distance and I stop, and then I first figure out where that 30 degree is to figure out where my baseline is, and then figure out what that 90 degree needs to be to create this vertical line, is much longer than I having to create my starting line, my ending point, putting the protractor here to figure out 120 and just simply making it 120. So if you remember these 4 angles, it's a lot easier to work with. So you have 120 degrees here, you will have 120 here, you will have 120 there. If you look at this point, this is going to be 60 And similarly, this is also going to be 60. Why? Because if I were to extend this line further, and if this was to be your 60, then this is to be 120. And as that is also 120, and in the end you are going to get a 180 on a straight line, therefore this is 60. So you have a 60 degree to play with, you have a 120 to play with, you have a 90 degree which is a vertical to play with, and you have a 30 degree to play with. Isometry, always remember, is a 30-60 concept. Okay, so if this is 30 degree and this is 30 degree, what you're remaining with is 60 degree on either side. So that's how they say it, but in actual, it's a 30 degree on either side. So if this is 30, then so is this side. So your product is never on the base. It is always elevated from the base. So if I have to show it to you, let's say in the camera view. So if let's say this is your base, then the product is not kept on the base, but it is kind of elevated like that. Both this side as well as where my thumb is this side, they are both going to be elevated at 30 degrees. But the vertical lines will always be perpendicular to the base. So that's how isometry works.